Hello, everybody, and welcome to another lecture in Geography 341, Weather and Society. I'm Dr. Zach Hilgendorf, and this is going to start the first of currently three kind of smaller lectures on weird or extreme weather phenomena. We've talked about some pretty extreme weather phenomena in the past. We've talked about hurricanes, thunderstorms, tornadoes, mid-latitude cyclones, lightning, all these random, intense weather systems that can pop up based off of atmospheric patterns and pressures. But derechos are the first of our currently three. We're going to be talking about derechos. We're going to be talking about um, a phenomenon known as a haboob, also known as a dust storm or a sandstorm. And then we're going to be talking about one that I had never heard of before kind of going into these lectures, and that was something called a meteotsunami. Um, and we're going to talk about those and another similar phenomenon known as a sesh wave or sesh. So that's going to be the focus here. All somewhat shorter lectures, nothing wildly long like our hurricane lectures or some of the other bigger stage setting lectures we had earlier on in the semester. So enjoy. I hope these are interesting to you. Many of them happen in our own backyard here in the Midwest, as we will come to find out here in just a little bit. So let's go ahead and dive in. So first off, what are derechos? You can see pronounced derecho or derecho. These are basically just widespread. We're saying widespread as in vertically or longitudinally distributed, or based on how it. We'll see a picture of it here soon. They're widespread, long-lived windstorms is really what they are. They're associated with bands of rapidly moving showers or storms. We've heard this name before. We've heard of bow echoes before. We've talked about hook echoes and other types of echoes in previous lectures. So, bow echoes or squall lines, we've talked about squall lines. You've probably not heard of quasi-linear convective systems. It's probably a new term for you, but they all kind of describe the same type of phenomena. A linear formation of storms with a pretty significant difference in pressure from outside to inside kind of thing. Uh, so derechos are produced by a family of what we call downburst clusters. So you've got basically, pressure differentials within your air parcels, right? And we've got, and the smallest of these, if we look at that graphic on our right, we have a microburst. Now, a microburst is just a localized column of sinking air, a downdraft. We've talked about downdrafts in the last few weeks. That's within a thunderstorm and is usually less than or around 2.5 miles in diameter. So, diameter of this microburst, you can assume somewhere around 2.5 or so or less miles. Um, Downbursts, sorry, microbursts are much smaller. Downbursts are 2.5 miles. Uh, so we go from microbursts, the smallest phenomena, kind of unidirectional for the most part wind patterns, to downbursts, which are coming from the downdraft through your thunderstorm. And as it does so, you've got air kind of diverging and going everywhere. You've got downburst clusters. So you can have a bunch of these going on based off that downdraft air coming out of your thunderstorm. And then we can kind of see our family of downburst clusters living within a storm system at the top, yellow one on the top there. So these phenomena were first described, or the word was first coined in 1888 by Dr. Gustavus Heinrichs at the University of Iowa, which makes a lot of sense once we start looking where some of these happen pretty regularly. This on the side here is an excerpt from his publication in 1888, Tornadoes and Derechos. It says, even before organizing the first state weather service in this country, I had noticed some of the peculiarities of the storm, which I now propose to call the derecho. The first publication of the map of such a storm was that of July 31st, 1877, in the special bulletin number 1 for the Iowa Weather Report for 1877. So way back, I mean, we're well over 100 years now. This phenomena was noticed. Um, Heinrich's distinguished, it was basically distinguished thunderstorm-induced straight-line winds from damaging rotary winds of a tornado. So you've got tornado, it's cyclic. Those winds are circulating. But in a derecho, the distinguishing factor is that you've got straight line winds coming from one direction, more or less. Um, so it kind of stems out of the Spanish word meaning right or direct or straight ahead. But this term was lost after Heinrichs kind of retired and wasn't using it anymore. Disappeared for about a century. Then in 1987, the term was reused, kind of brought back to light by the NOAA National Severe Storms Forecast Center, kind of a precursor to the Storm Prediction Center, by William Hurt and Robert Johns, two meteorologists for NOAA at the time. And they were basically looking at mapping the total number of derechos through the months of May and August for a period in the 1980s. We see here derechos, widespread convectively induced windstorms. So we're seeing, the upper Midwest spanning out to the East Coast. These are where the primary derecho occurrences were at this time. So been using it for a while. Like you said, it kind of went away, came back. So what is it? We can distinguish it from a tornado based off these more or less straight line winds. But if we look at what a derecho is, we can classify a derecho if a few things happen. We have a swath of wind damage that extends at least 650 kilometers long and 100 kilometers wide. It includes gusts of at least 93 kilometers per hour, or 58 miles per hour. And it includes several 121 kilometer per hour or 75 mile per hour or greater gusts. Those are the things you need to get something that can be classified as a derecho. Now, they can form in a few different ways. They're typically associated, as I said, with bands of showers or thunderstorms that kind of have this curved or bowed shape. And you can kind of see here, circling that. Notice how the cold front is bowed. That's what we're talking about when we're mentioning bow echoes. We'll see some GIFs here in a few slides to show exactly what that looks like on a radar, for example. So the term bow echo is based on how those bands of rain or thunderstorms bow out when strong winds associated with these storms reach the surface and spread out horizontally. A derecho comes from the long-lived bow echo or a series of bow echoes. These bow echoes usually arise from a cluster of storms, but also may begin from just a single supercell thunderstorm. As the rain getting ahead of myself. As our rain-cooled downdraft, so we've got our down sinking parcel of air being cooled by the rain as it does so. As that reaches Earth's surface, it spreads out horizontally. This downdraft marks the dissipation stage of that particular thunderstorm cell. The cooler, more dense air hugs the surface as it spreads, forcing lighter, warm, moist air up into the atmosphere. The boundary between the rain-cooled air and the warm, moist air is what we call the gust front. Oh, sorry. There we go. So here we are in stage 2. So if you've got tilting of that incoming updraft, it allows that cumulonimbus cloud to expand further, increasing the aerial coverage of rain, which in turn further adds to that cold pool of air underneath the thunderstorm, and thereby strengthens the gust front, causing it to bow out even more. You see, from where we were before, it was, smaller, much smaller than it is as that storm system starts to strengthen. The bowing of the gust front forces more warm air up, that is warm and moist, creating new thunderstorm cells. The process repeats itself. The additional rain reinforces the cold pool and strengthens the rear inflow of air, with the thunderstorm complex reaching a semi-steady state condition. At this point, there's a pronounced bow in the storm as seen by a Doppler radar, and an area of moderate to occasionally heavy rain near the center of the cold pool well behind the gust. So this is stage 2. Stage 3, as long as there are new thunderstorm cells forming on the gust front as it advances, replacing those older dissipating cells, that cold pool and rear inflow are going to continue. Also, all along the leading edge of the bow echo, thunderstorms may be producing downbursts and microbursts. About one half, or roughly 46% of bow echoes begin as unorganized thunderstorms. Another 30% form from squall lines, and about 1/4 form from supercell thunderstorms. If the bow echo, or a series of bow echoes, progresses more than 250 miles, 400 kilometers, with widespread wind gusts exceeding 93 kilometers per hour, 58 miles per hour, or greater, then that bow echo is then classified as a derecho. So this is kind of how we get them. This is how they form. There's a few different types. Uh, the type of derecho most often encountered during the spring and fall, so what we would typically see now, is what we call a serial derecho. Serial derechos are produced by multiple bow echoes embedded in an extensive squall line, often many hundreds of miles long, that sweeps across a very large area, both wide and long. This type typically is associated with a strong upper level trough, low pressure zone in the upper atmosphere, uh, with a strong surface low pressure system as well. An example of a serial derecho affected Florida, Cuba, and adjacent parts of the Gulf of Mexico, the Caribbean Sea, and the Atlantic Ocean during the early stages of what we call the storm of the century that happened in March 12th and 13th of 1993, which we can see here. So notice that red, that really, really intense color there. That's on the leading edge of that was where our derecho would be. So this event, this storm of the century, and this GIF is, a few of these are weird. They rewind and then restart. So it's not moving backwards. It's moving forward and then almost rewinding. I'm not sure why the creator of the GIF did that, but we still can see some really cool stuff here. So we're looking at Florida. If you can see, we're coming across central Florida in this image. But so what happened here is you have significant wind damage occurring across Florida, with measured wind gusts reaching a maximum of 96 miles per hour in the Tampa Bay area. Supercells and small-scale bowing segments within the squall line produced tornadoes and/or tornado-like damage over the northern half of the Florida peninsula, with some of the damage reaching F2, Fujita scale 2 intensity. 7 people were killed, 79 were injured from storm winds and embedded tornadoes as the derecho-producing squall line raced through the state. Storm winds blew down countless trees, power poles, and power lines and tore the roofs off of homes. Mobile homes were severely damaged and trucks were even overturned. So this is a serial derecho. So this is similar to, but different than our next type, which is a progressive derecho. So these are associated with a relatively short line of thunderstorms, typically 65 to 400 kilometers, about 40 to 250 miles in length. It's mainly a summertime occurrence. These derechos usually are associated with a stationary front, where the upper level airflow is parallel to the stationary front. So our upper level airflow, as you can see, our stationary front is here. We're parallel more or less to that stationary front in our upper level. Take those really quick. Progressive derechos may travel for many hundreds of miles along a path that is relatively narrow compared to those of serial derechos. Example of this type is the Boundary Waters Canadian derecho that occurred July 4th and 5th of 1999. In other cases, the progressive derecho and associated bow ecosystem begin relatively small with a narrow path, but over time grow to exceed 400 kilometers in width. The line of thunderstorms of a progressive derecho often begins as a single bow echo that evolves into a short squall line, typically with one or more than one embedded bowing segment. Such development occurred with the I-94 derecho over the north central United States on July 19th of 1983. Often these are associated with an area of weak low pressure at the surface. And you can kind of see the difference between the two of them. A serial derecho is the one we see on the left. That's just a single squall line with derecho forming on the leading edge. A progressive derecho, you can see this storm pattern on the right side here. It's from August 10th of 2020. And this is moving over Iowa into southern Wisconsin, Illinois, Indiana, and Michigan. So you can kind of see as it progresses at 9 a.m., 10 a.m., 11 a.m., we can kind of see how this storm changes. You know, we go from this relatively short here. By the time we get to the area over Lake Michigan, much bigger, much longer swath, although here it's kind of in its decay stage, it looks like. So a serial derecho, multiple bow echoes, strong low pressure. Progressive derecho, single bow echo, short line of storms is kind of how you can think of these two. So where do they form? We can kind of see two maps here. It's kind of a location and where and when they form. So derechos in the US most commonly occur along two axes. One extends from the Corn Belt, so upper Mississippi Valley, southeast into the Ohio Valley, and the other from the southern plains, northeast into the mid-Mississippi Valley. So here are serial, and here are progressive. During the cool season, September through April, derechos are relatively infrequent, but are most likely to occur from East Texas into the southeastern states. Although derechos are extremely rare west of the Great Plains, isolated derechos have occurred over the interior portions of the western United States, especially during spring and early summer. So we can see where they occur, and maybe a little bit more interesting is when they occur or how frequently they occur. Mostly we can see they are a May, June, July occurrence. But if we look at our map above the graph here, we can see where we live, roughly right about here. We can expect one derecho every 2 years or so. If you live in the southern portions of the state, maybe one derecho every year. If you live right down here next to, Arkansas, Missouri, Oklahoma, you can expect 4 derechos every 3 years. So, more than one derecho a year. And I'm sure if you've ever watched the weather, if there's ever been storms coming in, you've probably seen what almost could be classified as a derecho, or maybe you've lived through some. There were some that went through, so we saw southern Wisconsin and parts of Iowa, most of Iowa, Illinois, Indiana, and Michigan just a couple of years ago. Some pretty intense ones, actually. Fun, just simple fact here. My grandmother, when I was mentioning what my lectures were going to be for the next week, was saying I was going to do some fun extreme meteorology, and she said, "Oh, you should talk about derechos." So that's kind of how I got the inspiration to make this video. So she lives right about here in a little town called Comanche, Iowa, next to Clinton, Iowa, and they had that exact derecho that we were looking at on the slide before roll through and do a lot of damage. It was pretty interesting to listen and chat with her about it. So I'm sure many of you have lived through these types of storms before, and maybe just didn't know what they were called. It's not always widely used. It's more and more used these days. But yeah, so just a fun fact. So there are a couple other types. The third type of derecho is just known as a hybrid derecho. It's got characteristics of both, progressive and serial. The Southern Great Lakes derecho of May 30th to 31st, 1998 was associated with a pretty strong migrating low pressure system. However, the derecho path and associated bow ecosystem had many characteristics of a progressive derecho rather than a serial derecho. So we can see, and that's this storm that we're looking at right here. It can have, aspects of both. Sometimes it's more like a serial derecho, sometimes it's more like a progressive derecho. It just depends on the system and how that system is evolving over time. And then the last one is a low dew point derecho. In contrast to most derecho producing thunderstorm systems that typically occur in association with very moist air, bands of widespread wind producing storms sometimes occur in environments of very limited moisture. These systems are referred to as low dew point derechos. Such derechos most often occur between late fall and early spring in association with strong low pressure systems. And these are kind of a subset form of a serial derecho. So they're related to serial derechos more than progressive derechos. Couldn't find a good picture of one that wasn't just there's a lot of conditions that they don't really call these out. It's recognized as a kind, but it's not widely, mentioned and shown in nice GIF form. So here we can see similar system. This was that one that was moving through at the end of August. So let this play through just a couple of times. But you can see as that picks up and really starts to kick, you can imagine, the winds in there, derecho force winds, pretty intense, caused a lot of damage as the system moved across the Midwest. So watching this awesome GIF play by, this is where we're going to end this video. I hope you now know what a derecho is and know a little bit more about them and maybe can recognize them. So we will see you in the next video to talk about dust storms. So I hope you have a great day. Thanks.